hopefully will be available next week sometime, or on or before, maybe slightly after the 4th of July. So you'll be able, that'll be the, recording and the slides. All the slides will be available. So welcome, and we will wait maybe 2 more minutes and then we'll start. We'll start in about a minute, because we got a lot of material to cover today. Okay, let's get going, and when others join, hopefully they'll catch up. So welcome to the Bridges-2 webinar today. We'll have John from NVIDIA and Julian from PSC introducing the NVIDIA AI Enterprise suite that we are now making available on Bridges-2. Welcome to the Pittsburgh Supercomputing Center. I guess many of you may be familiar with us because I think many of you are either PSC users. So we've been around since 1986, joint project of Carnegie Mellon and the University of Pittsburgh. And we've been a national advanced computing center ever since. And we've, to some extent, shaped the evolution of advanced computing since then, but we've certainly kept pace. So our expertise is there. And in particular, this is under the auspices of the Bridges-2 project, which is Bridges-2 is the system pictured here, which probably most of you are familiar with. This is an NSF project, and we have this series of webinars under this auspices. Here's the leadership team. I'm Sergio. I'm the PI, and here's our leadership team, our co-PIs, and our project manager, Riaz, who's hosting today, our information security officer, who's always watching over us. So the Bridges-2 webinar series started, I believe, in 2023. And we do maybe 4, 5 webinars a year. It is a forum for the Bridges-2 community to learn and share ideas of achievements. You have a link there where you can see recordings from all the past webinars. So we're always looking at topics and speakers of interest to the community. And that, of course, would include yourselves. If you have suggestions for speakers and topics, please let me know. So today, I'm happy to introduce our speakers. First off will be John Coons, a key member of the NVIDIA AI Enterprise software team, who is a senior AI product specialist for generative AI and AI inferencing for the Americas. He has a stellar background, of course, and Today, he's bridging the divide of technical acumen and foundational business logic, leveraging his diverse background to bring a unique and valuable perspective to the generative AI equation. And then Julian, right here at BSc, is a senior software systems software engineer in the AI and big data team. Julian has a background that equips him to be a go-to expert for all things tech, and especially, of course, on the AI and big data side, where he plays a key role in supporting users, helping them maximize the performance of Bridges-2 and other systems. And as you will see, he will take over from the initial introduction by overview by John, and get into details of how the framework is deployed on Bridges-2. So finally, from me, some logistics here. So what we will do is, so we abide by the Access Code of Conduct. Access, of course, is kind of the National Science Foundation framework under which we allocate most of our resources. Of course, others we allocate through NAIRR, but that's the Code of Conduct. It's but all of us will be muted except the speakers during the presentation. And we will have 10 minutes at the end to answer questions live. But meanwhile, whatever questions you have, please type them into the Zoom chat. We might be able to resolve some, but anything that's left over will then be addressed by our speakers. And at this link, you will find the video recording, hopefully sometime next week, and also the slides. Any questions for me? If not, then let me stop sharing and invite John to take over.
All right. Perfect. So can you see my screen?
Yes.
Excellent, excellent. Okay, so by way of introduction, so John Coons, part of the NVIDIA AI Enterprise software team, focus more deeply on the technical side of implementation. But we'll kind of dive into what NVIDIA AI Enterprise is, what it covers, and a little bit of the history, and then some of the scientific use cases, for what we've built over the course of the last 30 years. So NVIDIA AI Enterprise is NVIDIA's approach more at the systems level thinking of how do we approach the tough problems that everyone faces. So starting at kind of the base of this, we look at the infrastructure management, offering key components, to facilitate cluster management and deployment of GPU drivers, making it easy for people to deploy. Our workloads are in large part containerized so that they can be easily deployed into multiple types of environments. If we move up the stack a little bit into kind of the data analytics, here's where we see accelerated data science kind of take hold. So if you are familiar with our Rapids AI, so things like QDF for accelerated pandas, QML for accelerated scikit-learn. Those types of libraries are a lot of CUDA-enabled libraries for accelerated data science that are under that are available as well as part of NVIDIA AI Enterprise. And then we also offer curated environments for PyTorch and TensorFlow underneath our AI model training and customization. And then the deployment of those models, how do we containerize all of that? So the optimization, all of those pieces. And then we move up to the AI application SDKs. So there are over 100 SDKs and frameworks that NVIDIA has built and supports over the course of many, many years. Those are part of the NVIDIA AI Enterprise. And then at the very top are the very easy to deploy what we call NIMs. NIM stands for NVIDIA Inference Microservice. So these are models and kind of workflows that we have taken, optimized for that. And many times we've done additional training to base models to make them more efficient, and then done fine tuning of those to make sure that they run optimally across the GPU hardware. And this is inclusive of other AI microservices as well. Just to give you an idea, kind of on the SDK side of things and frameworks. So, these are the supported frameworks that we have. Again, this slide, I'm not going to read through each one of these. I'm just going to highlight some of the more germane ones. When we look at, accelerated, medical advancements, certainly MONAI, NVIDIA is one of the founding members of the MONAI Foundation. So when it comes to analyzing, DICOS, DICOM data, if you're doing security-based data, and analyzing those 3D slices, MONAI is kind of a premier platform for that. And then Clara is a suite of computing platforms for AI healthcare, everything from genomics and drug discovery. Holoscan is more of a high speed. Think of this as like software defined medical devices and the granularity of data that you want coming off of that. So having a system that can handle that type of frequency, that's why we came up with the Clara Holoscan Rapids that I mentioned previously. Again, GPU accelerated data science. And then we'll focus a little bit more on Modulus, which is a physics-informed neural network framework so that you can build models that abide by the laws of physics. You'll also see in our documentation PhysicsNeMo, which is tightly coupled to Omniverse. So when we look at robotics, things that need to abide by the laws of physics. But Modulus is the framework that is the baseline for that. And then the graph neural nets, which have become exceedingly popular of late, we offer a couple of different frameworks for that. PyTorch geometric, so the PyG library for training those GNNs, and then the deep graph library, built for implementation and training of those graphs as well. So we'll dive a little bit deeper into Modulus. So it is open source, but when we look at NVIDIA AI Enterprise, we try to open source as much as we possibly can. There are only a few items that are closed source. Those are the ones that were at the very top of that stack. The microservices, those are in the closed source realm. Everything else we try to open source, make it open to the community. And what you get with NVIDIA AI Enterprise is really on the support side of the house. So if you run into a blocker, you can raise a ticket through PSC, be able to get help with that going forward. So this is really, for physics, machine learning, innovation, and collaboration. So it's a platform for building physics-based models and using architectures and algorithms that satisfy first principles. So everything that we do is based off of how things would operate in the real world. So we don't care about hypotheticals that don't have those restraints. We care about the things that do. As part of this, we also have the Omniverse extension. So if we want to take our simulation and put it into more of a visualization, we can do that through the Omniverse. So lots of models, data pipelines, the geometry and 3D point clouds that are in there. Triton Inference Server, all of these things kind of come together to make a framework that I can build and then deploy enterprise class models. So it is Python based. It's built for coupling data and physics. Very scalable from that respect. There are a lot of reference case studies. There's also a model architecture zoo. So if you need something to kind of base a new model off of, you can start with that zoo. It's interoperable with PyTorch. So if you have an R&D model that you've been working on, you can import that as well. But really, this facilitates a lot of the open collaboration within the physics scientific community. That's the intent of it, is to build better and more accurate models over the course of time via collaboration. So what it is not a purpose-built app. This is a framework. When you think of NVIDIA, we aren't going to build the last mile. What we're going to give you are the tools by which you can build that last mile to get to that enterprise model. So you can build it with the Modulus toolkit. And that's training data, create your network, you optimize that training. You can bring the testing data in, have your trained model, visualize those predictions via Omniverse, via that connectivity. And then look at the interoperability of it, how deployable is it, and then be able to publish that if you want to publish the model out into the public space. So those are kind of the steps that we see with Modulus. Again, it's a framework, not an application, but it's kind of built for that open experimentation and collaboration. Kind of shifting gears over into the BioNeMo. So one of the premise that NVIDIA has, that anything that has a language can be leveraged within a generative AI context. So biology has a language, chemistry has a language, physics has a language. So everything has a language and can therefore be put into the transformer construct and be built into a model. So when we look at the BioNeMo platform, it starts out with the framework on the left-hand side. If we want to look at training, kind of building the model, and then working our way through, we come up with the most common models that we see, especially in drug discovery. So what we did with those models, we took, improved upon them, did fine tuning or additional training and optimization of those to run across our GPUs, and we call those the BioNeMo NIMs, so the inference microservices. And then we also came up with representative workflows, how you could put these together to create a blueprint for activities that you want to accomplish. And we'll cover off on those as well, just a little bit. In the healthcare ecosystem, we see the target discovery. We may want to look at hit generation. What do we have that we have a high confidence level that can then be turned into a lead, and then optimizing the biochemical properties of that with lead optimization, and then into the preclinical imaging. Clinical trials are kind of outside of scope of where we're at, but we can still record that information, look at that as a ground truth. Did the models that we create, did those create results at the end, and do we have a high confidence in the efficacy of what we've created? Underpinning this is the NVIDIA BioNeMo. So all of the CUDA-X libraries, I think we're up over 800 different libraries now that we've created for specific workloads. Many of those are related to biology, digital chemistry. So putting that into the framework, if I want to train a model, or if I want to just leverage one of the models that exists already with the NIM, putting in my parameters, my information, and then I can furthermore put that into the blueprint, and then this can all run on the PSC hardware. So when it comes to the framework, this is very easy to build from modular components. So we modularize everything. If you want to train and customize a model, you can train a model from scratch, or you can customize an existing model, provided it's open weights, and then make those predictions, evaluate your model, and then publish that out. Come up with, again, an enterprise grade model that performs as you want to, that will accomplish what you set out to do, the tasks that you have. With the NIMs,
we do offer the best of both worlds with NVIDIA NIM. But first,
yeah, there was an audio on there. I didn't realize. With the NVIDIA NIMs, the inference microservices for generative AI, we do have NIMs that are associated to the BioNeMo as well. What this is a pre-built container with that optimized model. We offer industry standard APIs for interfacing to that model, support for custom models as well. So if you do customize, you can put it on the inside of this container and be able to serve it out. Domain specific code and the optimized inference engines. So that's something that We look at how quickly can we get to inference, how quickly can we generate results, and how can we accelerate that across the hardware better than anyone else does. Now, the NIM microservices that we have in BioNeMo for digital biology data, so this is all around the drug discovery. So if we want to do molecular generation, we have two different flavors of that with MolMem and GenMol. And then we have molecular pose prediction. If I want to create what that looks like, DiffDoc 2.0 is accelerated across the NVIDIA GPUs. And then if we want to represent the 3D structure of that, we have AlphaFold 2 and ESM Fold, both of those as containers so that you can put that into the workflow. If you want to do sequence prediction of proteins, protein MPNN is a model that we have as well. If you want to do a more complex prediction, AlphaFold 2 Multimer is another NIM that we have in the fold. And then the protein generation. So ESM1, ESM2, RF diffusion, and all of these can lead in and inform the CAD application that you're leveraging for the generation of that protein attachment, generation of molecules, whatever you want to export out to your CAD application kind of interfaces directly to that. So there's additional information in the slide deck on each one of these. I put that into the appendix. I won't go over it today, but it's there for future reference. When we look at the BioNeMo blueprint, so we'll cover off on just a couple of those. The protein binder design, virtual screening for drug discovery. Essentially we create workflows that are examples of how you can put together the NIMs, how you can put together application code to interface between those, and you can take these and make them your own. Very much open source. You can also experiment with them on build.nvidia.com, and I'll show you what that looks like at the end of the presentation. But we'll dive into kind of the first one, the virtual drug screening. So, if we want to optimize molecular, designs for multiple features simultaneously, I can take my protein database and be able to plug that in to AlphaFold. I can then look at the molecular generation using MolMem. So I can then put that over into DiffDoc and understand what does that look like? What is the potential for that particular protein to be able to dock, or that molecule to be able to dock with the other. So this allows you to actually iterate through, identify those virtual hits, be able to reduce that time. So you're not spending lab time experimenting. You can actually do it in a virtual environment. So that's one of the huge benefits of doing this in a digital way, utilizing things like the blueprints. On the protein binder design, so again, this is combining multiple of the NIMs to see what is going to give us the highest confidence level for protein binding. So you can explore kind of the vast design space for structures, looking for functional features, gives you that state-of-the-art speed and scalability over other approaches. And you can identify that high affinity for binding from smaller sets of designs to kind of scale it down and have a high confidence level before you move it into actual lab work, that this is something that you have a high confidence level that it will be successful at the end. Again, huge advancement in reducing the time for drug discovery. And then what this looks like, I'll just flip over to the build.nvidia.com site. If you want to take this on a test run, before you deploy anything out, we do provide this as a free service. So if you wanted to click on, say the protein binder design, and this is going to give you kind of a representation, and it gives you a few of the folded proteins. So we'll select a different one, and then we'll make a different selection on the MPNN outputs. So we're going to say carbon only insoluble, and then we can click design protein. And what this is doing in the backdrop, this is actually running on our infrastructure in one of the clouds, running on DGX Cloud. So this is going to generate the protein for us. And here we see the result. So kind of gives you an idea of how things can be strung together, and you can go out, test, see if what you want to create would fit within that construct, or if it gives you some ideas. And again, you can take the blueprints cafeteria plan, use what you need, leave what you don't, and build your own type of experiment based off that. But I'll go ahead. I think I am close to at time, so I will go ahead and hand it back off to Julian. Let me get back over to my screen here.
Yeah, I think Julian can just take over. Thank you very much, John.
Thank you.
All right, thank you very much. Give me one moment. Can you see my screen?
Yeah, very nice.
All
Thank
right.
you.
Okay, thank you very much. So, thank you for joining. I'm Julian Uran. I'm a machine learning research engineer here at the PSC. And I'm going to show you how to run the NIMs on Bridges-2. The purpose of this presentation is show you a couple of ways that we created for you not to make a lot of setup for getting those NIMs running. So the context is we have a lot of different NIMs available in the NVIDIA. We wanted to be easy to run those NIMs on Bridges-2. There are about 80 NIMs that are currently available on the NVIDIA website. And so the idea is to have each of them in an easy way to be started on Bridges-2. Regarding the Bridges-2 resources that you have available to use these NIM containers, we have different GPU nodes, but in this case, the ones that are compatible with the NIM containers are the H100 GPU nodes. So please have that into account. The V100 ones are not compatible with the workflows, but then the workflows that we have there will be reproducible, and then you will be able to start like batch or interactive jobs since we're running everything there with Slurm. And so the two main different ways of starting the workflows with the NIMs are to start them in batch mode, in which you can just specify the input for each of the NIMs, and then you start running the script for getting an output. Or you can do it in a more interactive mode in which you can launch each of the different components by hand. So you can, I don't know, send custom queries if that is what you would like to. That will be more flexible than the simple batch mode. So just choose whatever fits your research best, your workflow. And then for the different NIMs that are not currently running on Bridges-2, like are not configured yet, no need to build those. Just let us know what is it that you need, and we will get to configuring those and make them available. So let me show you how to get this running. So for the batch mode, the idea with this one is that it's quite easy to use. You can just set the inputs, and then you can run it using a slurm command. This will be for running the different things there, but just set the sequences. So you switch to the container that you would like to use, the NIM container that you want to use for any additional nodes that with specifics for how to run this NIM. You can find those in the README file. Then add the sequences that you want to process or the data that you want to process into the corresponding file and run it with SBatch. The result will show up in the output folder for the script, and that will be all. And then for the interactive mode, the idea with this one is that it's for running your own logic, let's say for doing the querying as you might need it. So you're going to start the server with a command in a similar way as the previous one. So just start the server and then run the querying the client as needed. There are a couple of versions, so you can run it using shell script or you can run it using Python as well. For the different NIMs, we have a set of files there. So the blue ones are showing the ones associated with the batch mode. So NIM auto.sbatch starts the NIM server. That is just basically an API that is containerized. And then it starts a client script. That will be this one, NIM client.sbatch. And so it will be sending queries to the server automatically. And that client will be reading the input file that you specify. And then for interactive mode, you have run.sh, in which you can run this for starting up the server, and then you can use nim client.sh or .py for querying the API interactively. There are a couple of additional files and resources overall for different NIMs. Those are a couple of those are colored here as green. So the catch folder is the set of preloaded model assets. Basically, for each of the different NIM containers, there are different downloads that have to be performed. So these are, let's say, 1 terabyte, 2 terabytes. The idea is to be able to point to these ones, and that happens automatically. So the server starts right away. Then let's take a look at it. So for example, for starting the interactive mode, this is how it will be. So starting an interact job on the cluster with the interact command, and then I'm switching to the containers folder for NIM, and then I'm switching into the AlphaFold2 folder in which we have the different files, and then switching into the interactive folder there to be able to take a look at the files that I was just mentioning before. So this is how it looks like. And then, for example, that run.sh that I mentioned before, this is what it has inside. So it has some internal variables, then other variables for setting the container name, because this is just a harness for running them. Then set some local disk paths for having the best performance on the cluster. Set some variables for the name itself, for example, the server port, and so on. And then it starts up the name server. So it's different commands, but you just have to run it with bash run, and that's about it. So you run it like this, and it's starting to show the output for how the server starts. In this case, it's now available and ready to be queried by the client. So for us to be able to know that it's indeed up, we can run a curl command or an API request to a different endpoint as well. So that endpoint is similar to what we were seeing above for running the queries, but then it's the input looks like this, like it's like V1 health ready. And so if we run this command and get an output saying like status ready, we know for sure that the NIM server finished starting up and it's ready to take all of the different requests. And then we can start the NIM client. In this case, I'm using NIM client.sh. And so this is the output that we are getting from the NIM server. This is sped up, so it usually takes about 4 minutes for a simple sequence, but that could be, let's say, 20 minutes or so for more complex ones based on whatever your input is. This is what it has inside. This is client.py. So basically, the sequence that you want to use, the server that you are pointing to, and in this case, it will be kind of automatic. Any additional parameters that you might need, send the request, and then write back the results. Similar with the name client.sh that I just used, might be a little bit simpler. So send the request. You can specify it as an argument as well, and then it will just output the results. Now for the batch mode, that is very similar, but then we're using an input file. In this case, I'm using nim auto input.txt that has this sample sequence. I'm copying that into my home directory to have it there, add any other ones that I might need. That is with the cp command. And then I'm starting the sbatch job with sbatch, NIM auto and so on. So, and you can see the command here. So it's like sbatch. I'm specifying where to output the log for the job, and then NIM auto.sbatch, and then what input queries, like input file to use, and where to write back the results. And that's about it. So it will automatically take all of the different lines in the input, will process them against the NIM server and give you back the results. And that's about it. This is the content of the actual script. It's basically doing the same as the script we were seeing before for interactive mode, but then apart from starting the NIM server is double checking with the script we also saw if it's already good for taking the requests, and then it's just looping through the file running the NIM client.sh script that we also just saw before. And so when you get the results, the same screen that we were seeing above, but then this one, but then with a little bit more formatting, it should look like this. So this is a result file for AlphaFold 2. So a Perrin data bank file that has the different information these files have. And so from here, you can take it and process it with file 3D mode or mol or any other library that you would like to visualize it as needed. So for the NIMs that are not there in the server, that are not like configured and working already, how to request new NIMs? The idea with this one is that we have right now a subset of just 4 NIMs working. Those will be AlphaFold 2, AlphaFold that multimeter that accepts multiple sequences, OpenFold 2, and then MSA search. You can see the list on the Bridges-2 user guide as of right now. In the navigation section, there are the NIM containers there, and you can see the up-to-date list. But then for any of the other NIMs that are not available right now on Bridges-2 that you might need for your research, you can go to build.nvidia.com, take a look at the models tab, and then you can filter by run anywhere, and then any of those we can get running here on Bridges-2. For letting us know which container and which NIM is it that you want, you can use the NIM container request form as well. So it's in the Bridges-2 user guide in the same NIM container section. So just click there, fill the form, and just let us know with the input field what container is it that you would like to have, and then we will handle the setup and let you know as soon as it's up and ready to be used. What happens on our end? So we will fetch the container, so download it, test that everything is working fine, configure different scripts to be able to use it in interactive or batch mode, and then document anything that might be interesting regarding that. We will add it then to the catalog and update the Bridges-2 user guide, apart from letting you know. And so that's about it. So the idea is for you to pick the workflow that you like the most or that fits your research the best, either batch mode for just specify the inputs in a file and run it, or interactive to have more flexibility and be able to run the server and the querying on real time and experiment to try to adjust it to your needs. So recap, you can find the containers that are already on the system. Take a look at the Bridges-2 user guide and the container section, NIM containers subsection. And for new ones that you would like to have, go to build.nvidia.com, take a look at models, filter by NIM type, run anywhere, and whatever fits your tasks, just let us know and we will get it running on our setup. Not all of the different containers might be compatible with our environment, but we will do our best to get all of them working here. But there are some slight limitations. And then just let us know with the form what is it that you need. If you run into any problems when running the NIMs, or if you, in general, just let us know. You can email us at help@psc.eu. That it's our PSC support email, and we will be glad to help you get up to speed. And then, as something additional, we're gonna have an open hackathon in partnership with NVIDIA. So please feel free to attend, register. There's going to be some optimization of GPU codes. This is going to be hosted by PSC, CMU Pit, and then NVIDIA themselves. So the deadline is quite soon, so June 25th. So yeah, you're welcome to. And please let me know, do you have any questions?
Thank you very much, John. Thank you, Julian. You guys have been attentive but very quiet. So open floor for any questions. I think Riaz, anybody can unmute themselves now, correct?
Yes.
So you can like ask directly, just speak up, maybe raise your hand, or you can also, of course, still use the chat. So what questions do we have? I should mention that, first of all, we should acknowledge that NVIDIA is contributing the licenses for all these containers to the community under the auspices of their contribution to the NAIRR, National AI Research Resource Pilot Program. This is a pro bono contribution that NVIDIA is providing along with resources on the DGX cloud. And so we thank them for that. They've chosen Bridges to host 80 of these licenses. And also, this was just an overview, but we do plan to have, as we gain experience and maybe you guys start using these on Bridges-2, we do plan to have follow-up webinars in coming months. So. Okay, why don't I take the one about the hackathon? So I would encourage you to read to go to the link and read the description, but basically it is, so first of all, it will be in September. And the idea is that a team of at least 3 people would bring a code that you guys want to optimize. I guess it could be that you are not using GPUs yet, or that you are using GPUs but want to optimize. Because we will have mentors from NVIDIA. We will also have mentors from CMU and PIT, and also from participating institutions. So, for example, you could be interested both in providing a team to work on a code, but also you might want to volunteer to one of your team members to be maybe different from the people who work on the code, to be mentors. So yeah. And the other thing is, yes, you need to, in order to work to do these, to use these containers, you do have to have an allocation on PSC, which you can obtain through Access or through the NAIRR pilot program. So if you are already a Bridges-2 user, if you already have an account, then you can go ahead and do what Julian said. If not, then you can use Access or the NAIRR pilot avenue to obtain an allocation. Okay, we have a question from Wen Lee. Julian, you want to yeah, I don't know. I think you would probably we would have to find a way for you to allow to host your web server and if I understand you correctly, you would like people to come and use your model and interrogate it, right? Is that what you're saying, Wendy? Um, yeah, I'm not sure I understand your question there. Now, in order to install the container, maybe Julian, can you quickly share the form?
Yeah, let's take a look at the form. So let me see.
So again, the form assumes that you are a Bridges-2 user.
That's right. Can you see my screen still? Oh, I guess.
Everybody see
yeah.
Julian's screen? Yeah.
Yeah, so yeah, this is the form. So the idea is for you to share a couple of details so we can know who you are, and then take a look at this part first then. What I was mentioning regarding the build.nvidia.com website, see any container that you might need that it's not already in the containers that are already configured. So the containers configured right now are AlphaFold, for which I just showed you the examples. And then, oh, there you go. And then AlphaFold Multimeter, OpenFold, and MSA Search. So any of these ones that you might want, for example, let's say you need GenMol and I don't know, audio to face 3D, you can go to the yeah, you can go to the forum and just let us know here whatever is it that you need, and then just submit the information, and that's about it.
Yeah, and as Julian said, we would for hosting we don't usually do that, but we can explore how to do that. Like it would have to be in your user space, and then we would have to take care of security considerations, all of that, but it can be done. We have a question from Dimutu. Can you unmute and ask your question?
Yeah. Thanks for the talk, Julian. Yeah, it's a nice presentation. I have one question about the interactivity using names. Can you please explain a little bit more? Like if I have my development environment locally, and if I want to connect to a BSC hosted name, how do I do that? Like through APIs or something like that?
Okay, so if I understand your question, the idea is you have your development environment, and then you want to run the queries against the server that it's running on PSC resources, but running your specific client on your
Yeah,
development environment. Is that right?
right. Yes, that's correct. Yeah.
Okay, so I think there are two main different options. So one will be for you to copy the different things, like recreate your client environment on Bridges-2 and then just run it from there. So you can perform the queries. The other one will be for you to connect directly from your development environment, like in your laptop or computer, to the server, but then that will require a couple of networking configs for you to be able to query directly, because the compute nodes are not available, like are not exposed to the ports to the open
Yeah,
internet.
yeah, that's what I was wondering. Do you
Mhm.
have to do any tunneling through the head node?
Yeah,
Um,
so we will have to take a look at that. There are a couple of options that we can explore. For
mhm.
example, it could be a tunnel, a network tunnel there through SSH, or we can, I mean, if there is a lot of requests regarding using the NIM servers in that way, we can look at other options that are simpler. But yeah, if you want to use them that way, just let us know via ticket, and then we can also generate the documentation for that specific path. Does that make sense?
Yeah, that's what I want to check. Yeah. Thanks, Julian.
Okay.
Yeah.
Mhm.
Okay, maybe John, would you like to take Carl's question there about parafold? I don't think it's there now, but yeah.
Yeah, I was just looking at the check. I don't think that parafold is in there from an alternative to the AlphaFold. But we are looking, actively at elements such as our Dynamo, where we're separating out, some of the components of the transformer models. But I is in terms of separating the CPU and GPU, I'm not sure if we have that. We're looking at, how do we separate on the transformer models, the um, kind of pre-fill away from the token generation. That's where Dynamo comes in. But I don't think that we have the parafold. But I'll have to get back with you. I'll check with the team and see if we're actually actively pursuing that.
Yeah, what I would comment is that here at BSC, we've done some work on AlphaFold to optimize the workflow and specifically on separating CPU and GPU. So we have a version on Bridges-2, not as a container, but if you're interested in that, just send email to help@bsc.edu and we will put you in touch with, we should be able to have you look at that also. But that's not a container. It's not supported by NVIDIA. It's just something that we did for a conference
Yeah.
in
Thank you.
collaboration with some folks at Temple University.
Yes, in addition to AlphaFold 2, we have OpenFold 2, which is a nice alternative. AlphaFold 2 and has a superior runtime and a little bit more customizability to it. I put a link to the documentation in the chat, and then there's also an instance of the NIM that you can interact with on the build.nvidia.com site. And I'll put that in the chat as well, but that's a nice alternative that has very tunable, very customizable interaction.
Thank you, Ben. More questions? As I said, we will have the recording of this session as well as all the slides, including those that John did not show. They're in his appendix. We will put those online. I think Riaz will send you guys an email once that's available. So then you can peruse them at your leisure. And as I said, as we go along and as you guys start, experimenting with these things, we will, depending on where the main interest lies, we will work with NVIDIA to schedule another webinar. We still have 7 minutes. So, if you think about this and there's any questions that come to mind, just tell us at help@bsc.edu and we will get back to you, or NVIDIA will get back to you. If you describe what you're looking for, then we'll find the right person to get back to you. But most of all, I think we would very much encourage you guys to start, experimenting with these along the lines that Julian laid out, either with the containers we already have or by requesting others that you might want to look into from the list. So, and also, please do consider applying for the hackathon if you want to work on a code. As we said, the deadline is July 25th for applications, and then there will be a peer review of the various applications, and you will be informed, people will be informed if they can then participate in September. I think the link shows kind of the timeline of the events in September. So we look forward to maybe seeing some of you there. So if there are no further questions, then I think we can wrap this up for today, and we'll start working on this. Thank you again, NVIDIA, for this great contribution to the community, and we will definitely engage you in supporting our community. Thank you. Bye.